Good afternoon to one and all. Welcome to Professor Alladi Ramakrishnan Distinguished Lecture, organized jointly by the Academy of Sciences, Chennai and the Institute of Mathematical Sciences, Chennai. This lecture is the part of monthly lectures organized by the Academy of Sciences, Chennai. Given that this is the birth month of Professor Alladi, there is no better time to have a lecture on Professor Alladi Ramakrishnan. Now, I would like to call Professor G. Anna Balagan, Secretary, Academy of Sciences, Chennai, to deliver welcome address.
Thank you very much. Good afternoon to one and all present here. The Academy of Sciences, Chennai organizes Distinguished Scientist Lecture Series on the day or month of Distinguished Scientists. In this way, so far we have conducted 2 lectures. In the month of June, we have conducted the Distinguished Lecture Series to commemorate Professor P.T. Manoharan, and in the month of July to Professor M. Anandakrishnan, and this month Professor Alladi Ramakrishnan, and next month we are going to conduct for Professor Natarajan, Department of Inorganic Chemistry, University of Madras. So now we are gathering here for the Alladi Ramakrishnan Distinguished Lecture Series lecture today. You know, the Alladi Ramakrishnan was an Indian physicist and the founder of this Institute of Mathematical Sciences called Math Science in Chennai. He made his contribution in particle physics, algebra of matrices, special theory of relativity, and quantum mechanics. He had his early education in PS High School, that is in Mylapore, Madras, and graduated from Presidency College, affiliated to University of Madras, Chennai, and he got BSc Honours degree in physics from Presidency College. Ramakrishnan started working with Homi Bhabha at TAFR, and during 1957 to 58 he visited to Institute for Advanced Study in Princeton. It was the Institute of Advanced Study that inspired him to start the similar institution in India. That is the best story of this Institute of Mathematical Sciences, now Chennai. Professor Ramakrishnan is noted for his work in quantum mechanics on giving a prescription of transition from Pauli to Dirac matrices. So such a wonderful distinguished scientist. So in order to commemorate the Professor Alladi Ramakrishnan, we are now here to start this lecture. So today's our chief guest, Professor Parthasarathy, he is the close associate of Dr. Alladi Ramakrishnan. He is the chief guest. He is going to share with his experience with the Professor Alladi Ramakrishnan, and so it is my pleasure to welcome the chief guest, Professor Parthasarathy, on this occasion, and also welcome to our former president, the Academy of Sciences, Chennai, and founder HOD of Department of Nuclear Physics, Professor V. Devanathan, and the advisor of the Academy, Dr. T. Ramasamy, former Director General CSIR, Government of India, Professor Marudumuthu, former President and former Vice Chancellor, Madurai Kamaraj University, and Dr. Ravindran, the Director, Institute of Mathematical Sciences, Chennai, and Ajit Samal, Professor, Institute of Mathematical Sciences, and faculties of the Institute of Mathematical Sciences, office bearers of the Academy, fellows of the Academy, professors from other institutions, and welcome on this occasion for this distinguished lecture series. Thank you.
Next, I would like to request Professor N. Vasudevan, Treasurer and Convener of the Academy of Sciences, Distinguished Scientific Lecture Series, to tell about the lecture series organized by the Academy of Sciences. Professor N. Vasudevan.
So, good evening to one and all assembled here. Professor Parthasarathy, the speaker for the day, Professor Ravindran, the director of the institute, Professor T. Ramaswamy, the former Secretary DST, Professor Srinivas Rao, Professor Radhakrishnan, Dr. Anbadagan, Dr. Stephen, and all the professors who have assembled here from the Institute of Mathematical Sciences as well as from other institutions, the staff and students from the different institutions who have gathered here. So, good afternoon to all. It is my privilege and duty to talk today about the program for which we have gathered here on behalf of Academy of Sciences and also jointly with the Institute of Mathematical Sciences, Chennai. So the Academy of Sciences, Chennai was instituted in 1976, and since then we have been conducting so many programs from the as an independent body. To say a few things, we organize popular lectures by different people on different subjects, and then we also have summer schools which regularly being conducted during the summer months for roughly three weeks or minimum of 2 weeks programs. So we conduct on many subjects, for example, mathematics, physics, chemistry and biology. These are the 4 subjects we conduct regularly every year without non-stop we keep on organizing. Then we also have Olympiad program in physics and chemistry, that also we organize. So it helps a lot for the PG students who are ready for the competitive exams, etc. It helps a lot for them. And we also have instituted several awards, Young Scientist Award, as well as Senior Scientist Award, and now the Lifetime Achievement Award, etc. So this lecture being what we call it as a distinguished lecture series. So we call it as a series because we conduct this program throughout the year. Every month we organize we select one eminent scientist who have served in the state of Tamil Nadu or who was born in the state of Tamil Nadu. So in that series, now this is the third in the series. So already we started this program in June 2022. So that was the month for Professor P.T. Manoharan. So we organized it jointly in IIT Madras, and last month, that is July, so Professor Ananthakrishnan's birth month. So we jointly with Anna University, we organized the program last month, almost same time, 27th we organized it. Now this month we requested Math Science to have this program of Professor Alladi Ramakrishnan, who was also the founder of the institute. So I also thank the director and the staff members who have readily accepted this program to hold it jointly in mathematical sciences. So this series continues. So next month, September, we have Dr. P. Nadarajan's birth month. Actually 17th is the birth date, so we organize that one. So like that it continues. Then we have Dr. Naidoma and G. N. Ramachandran, and then we also have C.V. Raman next following up, and then Srinivasa Ramanujan's lecture, etc. So like that every month we have planned one particular scientist. It goes continue. So next year also we have a series of lectures. So we try to hold it so that for the benefit of the society, the younger generation in the state, so that they will get benefited, because each lecture series falls on different disciplines. So this being a mathematical sciences, next month it will be in chemistry, so inorganic, particularly inorganic chemistry. So like that our aim is to spread the knowledge to the society in the state, and mainly we try to invite many of the students and academy people, etc., to hold this lecture as a big event. So in this series, that is what we are planning this program, and because this type of lecture will produce two things, two important things. That is, one, we try to come to know, we celebrate the particular scientist. After some 20-30 years, nobody knows about him. That is what is happening really. Okay. So the younger faculty members or the junior students, etc., may not be knowing about Professor Alladi Ramakrishnan. Okay. So like that, many other people also, it is the same case. Okay. So we try to bring out the reminiscences of the particular scientists by this way, and also it also helps in transferring knowledge. We ourselves learn something from the other person, and also the students get benefited by this lecture. So that is one interesting aspect of this. So we continue this program. We call it as a distinguished lecture series. Okay. So I should thank all the faculty members here that for this program to be held here in a nice auditorium what we have here. Okay. So Professor Alladi Ramakrishnan is not a new person to me. Professor Alladi Ramakrishnan is known to me because though he is in his field is mathematics. I am not. Mathematics is not dear to me, but I used to attend his lectures. After his retirement, he used to conduct weekend classes or monthly lectures in his residence, in his premises, within his in his house. He used to conduct. I used to go. I used to attend because I get some new information from that. Though I do not know much about the mathematics, deep into the mathematics. So I learned some of the things which during those lectures. So I know Professor Alladi Ramakrishnan and also his son and so on in their family, etc. So it is I should thank all the people who have assembled here for this happening today. This event, what I think, each event is I consider it like a yagna. Okay, I'd say. So our scriptures talk about several yagnas. Okay, of course, for example, Bhagavad Gita talks about nearly 12 yagnas. Out of that, there are 5 yagnas which are all which is of important. Okay, Dravya yagna, Yoga yagna, Tapo yagna, Swadhyaya, and Jnana. These last two, Jnana yagna, that is Jnana yagna, is nothing but learning something new. Okay, that is what we try to get some new information, etc. So that is what we try to do. That is what the educational institutions also do, what the students benefit, and also Academy of Sciences as an independent body, as a non-profit body, also try to have such type of activities so that society prosper and to help in the state in a larger way. Okay. So with this short information about this lecture series, I thank one and all who have assembled here to conduct this program in a grand manner here and a successful manner. Thank you one and all.
Now I would like to call Professor V. Ravindran, Director of Imsc, to deliver presidential speech. Professor V. Ravindran.
Good afternoon. On behalf of IMSc, it's a pleasure to invite all the academic members, also the speaker, Professor Parthasarathy, for this event to recollect what Alladi did to this institute. Alladi, of course, is dear to all of us because he was the one actually who conceived this idea of having an organization of this kind. I probably would not have thought that we would have institute with 4 different groups all doing wonderful things, and so it's an occasion to actually to celebrate. Of course, this is the year that we celebrate 75 years of independence, and also the year we celebrate 60 years of IMSc, and having an event of this kind is really fitting very nicely with activities that has been happening in IMSc. So I'll begin by thanking Academy for having a nice idea of this kind to organize a program to remember Professor Alladi, particularly in the month when he was born actually. As you all know that this is, he was born in sometime in August actually, 9th August I think. He was a founder of the institute, and this is the week that DAE has asked us to celebrate what is called Iconic Week. And when they contacted me that we should have a program of this kind, I thought, this is the right time to have, because DAE is actually organizing this Iconic Week to actually showcase that what DAE and DAE staff have been doing this to country actually. In what way we have been contributing in last 60 years. I would consider this is also one of the important things that we have contributed through doing good science and mathematics in the country. So I think it's an important event to sort of highlight this our works. My special thanks to my former teacher, Professor Parthasarathy. I am also meeting him after a very long time, and I learned physics from him. Particularly, there's something called quantum field theory, and he was a teacher to me. So I used to go and lecture in front of him. Today he's going to lecture in front of me. That will be a nice thing to happen. I'll also like to mention that the Math Science Institute is a proud member of rich academic and intellectual ecosystems in Chennai as well as in India, and having an association with Academy, which is just next door, is really an opportunity. And in fact, as a member of the institute, I would like to have more such occasions in future, and I request all of you to, time to time visit us, organize programs. You have been doing a lot of outreach programs. Our institute is also known for this outreach. In fact, I had given a set of lectures in one of your outreach course, and I request you to reach our staff, physics and mathematics and computer science, computational biology, to give lectures to college kids, school kids and things like that, because you have been doing this, and we are happy that we are part of this event. So again, on behalf of IMSc, I welcome you all again for this nice event. I won't take much time because Professor Parthasarathy is waiting to tell us about his interactions with Professor Alladi. Thank you.
Now I request Professor A. Stephen, former Secretary, Academy of Sciences, to introduce the speaker.
Good evening, one adult present here. I am just replacing, instead of secretary, joint secretary, I am just introducing today's speaker. Anyway, I am really happy because one way I am junior to him, because he did his BSc, MSc from St. Joseph's College, Trichy. At that time it was a University of Madras, and also he completed his PhD from Department of Nuclear Physics. I was told by our former President of Academy of Sciences, Professor Devanathan, Professor Alladi was instrumental in creating theoretical physics as well as nuclear physics at University of Madras. So one way it is a bonding for me to introduce Professor Parthasarathy. I am really happy to introduce Professor Parthasarathy to the gathering. After his PhD, Professor did his postdoctoral at Paris, France. He joined the Institute of Mathematical Sciences in Chennai after his postdoctoral studies. After his retirement in 2006, he was an adjunct professor of Chennai Mathematical Institute till 2020. He received a gold medal of securing first place in MSc and National Science Talent Search Fellowship, and he was the elected fellow of the Tamil Nadu Academy of Sciences. Previously it was the Tamil Nadu Academy of Sciences till 2014. Now we have changed for some administrative reasons. He has published more than 110 research publications in leading international journals, and he authored 2 books. His main field of interests are weak interactions, quantum field theory, quantum chromodynamics, and higher dimensional gravity. He proposed, along with K.S. Viswanathan, the new variety of fermion, Q fermions, in 1991, and he solved the instability problem in quantum chromodynamics and proposed a confinement mechanism. He proposed a cosmological model without the initial singularity. So I am not the field of working in quantum field theory. Anyway, just I am really happy to introduce today's speaker. And also I like to say one word about Alladi Ramakrishnan. I was a student of nuclear physics in the year 1989 as a MPhil student. I was an MPhil student. Still I could hear the voice without any, he used to give academy lectures without any mic. Such a tremendous, elegant voice. Still I could remember that voice. I think one way our Professor Devanathan was a student of Alladi Ramakrishnan, and similarly Professor Parthasarathy also a student of Professor Devanathan. There's a chain going on. So thank you very much for this wonderful opportunity. Thank you very much for all the research scholars and scientists of IMSc. Thank you.
Okay, so let's welcome our speaker today, Professor Parthasarathy, to deliver his lecture.
Good evening. Respected Director of this Institute, Professor Ravindran, and Office Bearers of Chennai Academy of Sciences, my friends, Professor K. Srinivasa Rao, T.S. Radhakrishnan, and T. Ramasamy. We were hostel mates 1969 onwards, 50 years back. I am very glad to be here in this hall to speak on Alladi Ramakrishnan, theoretical physicist. I will confine to the academics, mostly academics, and so this meeting is organized by Chennai Academy of Sciences and Institute of Mathematical Sciences, the two institutions created by Alladi Ramakrishnan and formerly called Tamil Nadu Academy of Sciences and Math Science. I had the privilege of admiring Alladi at a distance and then closely. I still remember my first meeting with him was in 1969. I joined Professor V. Devanathan for PhD. After a few months, I attended the marriage reception of his brother, Ara Amudan, at Rayapeta Woodlands. We, the students of Professor Devanathan, G.N.S. Prasad, P. Ramasamy, went. There were Professor P.M. Matthews and other faculty members of AC College. Soon there was a commotion and the atmosphere was electrified. Professor Alladi arrived with his wife. That was my first seeing and meeting him. When doing PhD, usually we get kind of either frustrated or disappointed and not getting good results So we used to go to math science. I had a cycle all the way from AC college to math science to listen to Alladi's talks and rejuvenated, no doubt about that. He was very optimistic and encouraged young minds to do original research. For instance, I still remember he announced a lecture in which you can learn Feynman diagrams in 5 minutes, but that was a bit exaggeration. But he introduced the idea of Feynman diagrams to us. I joined the Imsc in 1977 as assistant professor, and I had the opportunity to observe him at close quarters. I continued my work on weak interactions in nuclear physics, muon capture. He kind of advised me that is not going to get you anywhere. You should change. You should work on quantum field theory and then the upcoming Salam-Weinberg model, which has become a theory a little later. Even after his retirement, he used to call me to his house to explain his ideas in the special theory of relativity. I always liked meeting him. His advice and encouragement still reverberate in my ears and my mind. Alladi Ramakrishnan, born on 9th August, so this month is his birth month in 1923, to Sir Alladi Krishnasamy Iyer and Lady Venkalakshmi Ammal, and had his school education at PS High School, Mylapore, and college education at Presidency College, Madras. He had a keen interest in theoretical physics from the beginning. His father was a leading lawyer and member of the committee to draft the Constitution of India. So Alladi, to satisfy his father's desire, got enrolled in law, passed the exams with the gold medal in the Hindu law. His mother realized his passion for physics and convinced his father to let her son pursue his dreams. Alladi did BA honors at Presidency College, Madras. His desire to do theoretical physics was kindled. Do you have a pointer here? This is the pointer? No. Or I have it one. The first button is the one. Oh yeah. So his desire to do theoretical physics was kindled in 1943 when he heard the inspiring lecture on meson theory, which was Hideki Yukawa proposed that by Professor Baba, and that was his desire was kindled at that time. During the final practical exam, he had a torsional oscillations, which we do it, the big disk, and it keeps on rotating. And when he was doing the experiment, the disk slipped and fell with a big bang. The external examiner, Mr. Mandalam Iyer from St. Joseph's College, was not happy, and Alladi did not get full mark. Alladi told me that because of that, he could not get university first rank. So mesmerized by Professor Baba's talk, Alladi decided to go to Tata Institute of Fundamental Research, Bombay in 1947 for research. He stayed in Hotel Taj, and the stay was supported by his father. He was one of the first members of TIFR. With him were Abraham, K.K. Gupta, and P.C. Vaidya. Vaidya is known for his Vaidya metric. Baba introduced Alladi to cascade theory and the fluctuation problem in cosmic radiation. The number of particles multiply as a function of distance. So this study required probabilistic analysis of the distribution of discrete number of particles in continuous energy space. Baba allotted Alladi to consider cascade multiplication in cosmic ray showers as a stochastic process. Alladi, after some initial struggle, they both tried and they found the expression for a kind of a joint probability distribution for different energies. When the energies coincided, the probability vanished, which was not true. So that was the difficulty they faced. Alladi realized that instead of assuming a discrete set of energy states, we should divide the energy range into n intervals, making the sub-interval smaller as n tends to infinity. We assume that an event occurs with the probability proportional to the small interval. The occurrence of two particles in the interval is proportional to the square of this infinitesimal interval and therefore can be neglected. That was his premises. So thus only one particle can be accommodated with the probability proportional to the size of the interval, and no particle lies in it with the probability nearly 1. So in an infinitesimal energy interval, there can be one or none. I pause here and make a comment. This looks very similar to the property of fermions in quantum states. You can put only one fermion in a quantum state. And this was pursued by George Sudarshan S.K. Srinivasan, but that analogy with the fermion is not perfect. I can elaborate it on a different occasion. This idea of Alladi led to the formulation of product densities or density correlation function. We will see a brief account of that. These are precisely the functions one should obtain by multiplying the mean values in the discrete case with the density of states, but this direct approach obviates the confusion of a limiting process which gave zero probability when the energies coincided to the joint work of Baba and Alladi in the beginning, and gives the correlation function correctly now. When two energy levels coincide, there was a contribution coming from the degeneracy, and therefore the probability was not vanishing. So thus a stochastic variable n, which is the number of particles, taking discrete values, depends on a continuous parameter E or thickness T, which means the depth in the cosmic ray coming down. The use of product densities greatly simplified the treatment. Such processes are called stochastic point process, as the continuous variable energy or thickness for specific values represents a point in the energy or thickness axis. So let's give a brief summary or brief introduction. Let n of E of t, E for energy, t for thickness, the number of particles of specific energy at particular thickness t, be the stochastic variable, this number of particles with the parametric values less than E at some thickness t, we suppress t hereafter. Then dn of E is the number of particles in the energy range E and E plus dE. Alladi assumed that the probability that there occurs one particle in the infinitesimal dE is proportional to dE, while that for the occurrence of n particles is proportional to dE to the power of n, and dE is infinitely small, therefore this becomes vanishingly small. Then the average number of particles in dE denoted by script E of dn of E is represented by a function f1 of E such that curly E of dn of E is f1 of E times dE, denoting the probability that n particles occur in dE by P of n. We have P of one particle is f1 of E times dE plus order of dE squared, which is infinitesimally small. P of 0 is 1 minus f1 of E. P of n is order of dE to the power of n greater than 1. So this is the beginning, this is the premises he started. The nth moment of the distribution is given by script E of n to the power of r is sigma n power r P of n. So if you use P of 1 as something and P of 0 is 1 minus, P of n is order of dE to the power of n, which is negligibly small. You see this is script E of dn of E using P of 1 and P of n. So by forming the product of the stochastic variables dn of E1 and dn of E2, its expectation value has been defined as script E of dn of E1 times dn of E2 is f2 of E1 comma E2 times dE1 dE2, where f2 of E1 E2 is the product density of degree 2. The right hand side is also the joint probability that a particle lies in the interval dE1 and another in dE2 when the intervals do not overlap. When the intervals overlap, you can see that the degeneracy gives a contribution. In the formulation of product densities or density correlation function, another name, these are precisely the functions obtained by multiplying the mean values in the discrete case with the density of states. Alladi's approach is direct. In the case of Alladi's work in the beginning, they have to do a limiting process. So this avoids the limiting process and gives the correlation function correctly. When the two energy intervals coincide, there is a contribution from the degeneracy. Baba was kind of skeptical about Alladi's work. Alladi used to tell us, Srinivasa Rao is a standing evidence, that there was a mathematician called Kosambi in TIFR, and he didn't approve of this approach of Alladi, and Baba put his weight on Kosambi's judgments, and so Baba was not willing to accept Alladi's method. So Alladi reluctantly left TIFR and went to Manchester to work under Professor Bartlett. Professor Bartlett consulted his colleague Professor D.G. Kendall, who approved Alladi's work. His work appeared in the Proceedings of the Cambridge Philosophical Society in 1950, and that formed his PhD thesis. That was enough according to the professors Bartlett and Kendall, but he has to spend 2 years with the residency requirement in UK. Further work on product densities, Alladi gave a talk on the applications of stochastic process to cascade theory at Max Planck Institute in Göttingen, and Professor Heisenberg, the famous uncertainty principle in quantum mechanics, Heisenberg. I will recall this little later, a few sheets later, heard this talk. His comments made Professor S. Flagge of Springer-Verlag invite Alladi to write an article on stochastic processes with the emphasis on product densities, which appeared in the Handbuch der Physik in 1959. He joined the physics department at the University of Madras. As a reader in 1952, he was soon promoted as professor. With Professors P.M. Matthews and S.K. Srinivasan, he developed the method of product densities to astrophysical problems besides cosmic cascades. Soon Professors R. Vasudevan and N.R. Ranganathan joined him in this venture. Their works on the problem of fluctuating density field that came up in the studies of the Milky Way, the distribution of stars, attracted the attention of Professor Chandrasekhar, who communicated the studies to Astrophysical Journal. I pause here and I want to make a pleasing comment on Chandrasekhar now. In 1979, I think, I attended a conference in Vancouver, High Energy Physics and Nuclear Physics. You must have all heard about the physicist by name Valentine Teligdy, Borgman-Teligdy equation. He did experiment, he is an experimental physicist. He and Saclay group and the Belgian group did experiments, and their experimental paper referred to my work with Devanathan on the recoil polarization. So I was very happy. So in the conference, one afternoon I was sitting in the table and I saw Teligdy walking towards the table and sat before me, and he spent 45 to 50 minutes with me on talking about muon capture. I was very happy, very pleased. At that time he mentioned, I sit in the same corridor as Professor Chandra. He used to call him Chandra in University of Chicago. And he said, whatever Chandra does is beautiful. He used to write, Chandrasekhar used to write something on the paper and he may not like it. He used to, do like this and throw it. Even that was beautiful according to Teligdy. And he was not an ordinary physicist, Teligdy. So Chandrasekhar, who communicated the studies to the Astrophysical Journal of the Alladi and the P.M. Matthews, S.K. Srinivasan's work. When Alladi discussed his work with the Professor Sir C.V. Raman asked him to examine the early stages of stochastic process. That means, the previous, going back if you want to call, the inverse probability in some not very strict sense. This resulted Alladi's work on inverse probability in stochastic process, which he presented at the Indian Academy of Sciences in 1955, and Sir C.V. Raman had Alladi elected as a Fellow of Indian Academy of Sciences based on this paper presentation. No recommendations otherwise. A formulation of product density methods to include the occurrence of multiple incidents was proposed by Ramakrishnan and S.K. Srinivasan. A Q generalization of product densities was made by myself and Professor R. Sridhar in 2004, and we obtained Q Bell numbers from probabilistic viewpoints. I had the opportunity to present this in a seminar on stochastic point process. The volume was edited by S.K. Srinivasan and A. Vijayakumar in 2003 in the august presence of Alladi Ramakrishnan himself, the creator of product density. The year 1957-58 was a turning point. At the invitation of Professor Oppenheimer, the director of Institute of Advanced Study, Princeton, Alladi visited the institute, and when he returned, he had a desire to start an institute in Madras. Now, talking about Princeton, the members of the faculty in Princeton, I know two of them. One everybody knows, Edward Wheaton and then A.M. Poliakov. They are given huge, fabulous remuneration, salary, and no commitments. Absolutely no commitment, no teaching. Whatever you want to do, you do. So he wanted to, this is a double-edged weapon, okay? Whatever you want to do, you do means one can also keep quiet, saying I am attacking important problems. He had a desire to start the institute, an institute similar to that in Madras. And how that happened? Now I come to the theoretical physics seminar. There was an emphasis on high energy physics and elementary particles by Alladi after the return from Princeton. In order to encourage studies in theoretical physics, he gave lectures on quantum mechanics and other advanced topics at his spacious house in Mylapore. Many bright students such as Professors V. Devanathan, G. Ramachandran, whose student is the present director of this institute, A.P. Balachandran, T.K. Radha, Indumati, Tunga and G. Bhamati took active participation. Professor V. Devanathan was the seminar coordinator. Alladi introduced the concept of four vectors in Feynman diagrams and scattering theory in Madras for the first time. I think that after TIFR, this was the only center in India to discuss such advanced topics in high energy physics. Alladi frequently visited colleges and lectured on latest topics to inculcate a desire in the minds of young students to take up theoretical physics as career. He arranged conferences annually and encouraged college teachers to attend so that they can propagate the young minds. Professor G. Rajasekaran told me that Alladi lectured on isospin at Madras Christian College when GR was a graduate student, and Alladi introduced isospin matrices with their algebraic properties when almost none heard of matrices at that time. Alladi rightfully believed that by meeting experts and listening to them, students get inspiration and motivation. He invited his distinguished physicists and mathematicians and hosted them. Some distinguished scientists who lectured were Professor P.I.M. Dirac, 1954, C.F. Powell, 1955, Bruckner, A.M. Lane, 1959, George Gamow, 1959, Abdus Salam, 1960, Niels Bohr, 1960, Murray Gell-Mann, 1961, Dalitz, 1961, Chandrasekhar, 1961, Leonard Schiff, that two F's is missing, 1961, George Sudarshan, 1962. He made important contributions in studying Feynman propagator and its decomposition into positive and negative energy parts. This probably it was influenced by his work on inverse probability. Probably. He reinterpreted positron as tracing back in time. This work has been cited by Professor S. Weinberg. In his research in high energy physics, his students Balachandran, T.K. Radha, Tunga and G. Bhamadi took active role and had their PhD thesis. Alladi enlarged his research by studying meson scattering and production. Professors V. Devanathan and G. Ramachandran were actively involved in this area, and later Professor Srinivasa Rao took the flag. Professor R. Vasudevan and Ranganathan began their studies in many body problems. Creation of math science. When Professor Niels Bohr came to Madras, students of Alladi attended his lectures and Bohr listened to their studies. He was hosted by Alladi in his house. You can see the picture in the corridor with the Bohr with the Alladi. When Bohr returned to Delhi, he was asked what his impressions about science in India. Professor Bohr said two things impressed him: the massive Tata Institute of Fundamental Research in Bombay and the small group of students trained by Alladi Ramakrishnan in Madras. This statement of Bohr sparked Prime Minister Nehru's interest. Mr. C. Subramaniam, Cabinet Minister, arranged a meeting at Raj Bhavan between Nehru and Alladi with his students. When asked by Nehru what he wanted, Alladi asked for an institute for advanced fundamental research in mathematical sciences like the one in Princeton. The miracle happened. Alladi used to tell, this is something which I always say, when some people in authority asks you what do you want, you ask for a big thing, as in Tirukkural, ulluvadellam uyarvullal. You did not ask for a promotion, ask for a big thing. It may happen, and if it happens, good. It's like kind of the joke. This joke is attributed to Abdul Salam. He was trying to work on many areas. Some people were skeptical, and he used to tell this in the seminar hall, that once a wise man was throwing yogurt curd in a lake. So some passerby asked him, what is that you are doing? No, I am trying to convert the lake into curd. So the passerby, I think he must be a fool. The wise man replied, imagine if it works. So something which we should take some risk in doing research. If it works, good. The Institute of Mathematical Sciences was created in 1962 with the Alladi Ramakrishnan as the director. The institute was inaugurated by Professor S. Chandrasekhar on 3rd January 1962. Alladi wrote to many eminent scientists and they responded giving their wishes. It is unbelievable to see the telegrams by so many top class persons. So much impression Alladi created and his students. The telegrams were given by Professors Abdul Salam, Niels Bohr, Werner Heisenberg, Murray Gell-Mann, Richard Feynman, or Dalitz, T.D. Lee, C.N. Yang, Marshall Stone, Bartlett, Kendall, Mott, P.A.M. Dirac, H. Yukawa, Glaser, Robert Marshak, Richard Bellman, Eli Schiff, George Gamow, M. Shapiro, V. Weisskopf, Abraham Pace. The genuine students with their devoted teacher and their honest efforts did not go unnoticed. During his tenure as director, many mathematicians and physicists visited and gave lectures. Some of them, Hans Bethe, that was 1970, and Professor K. Srinivasa Rao, G.N.S. Prasad, and myself, we were in charge of taking notes of Hans Bethe's lectures on nuclear matter theory. And even before Hans Bethe arrived, we went to the Madras University Library and took the papers of Hans Bethe on nuclear matter theory, read about them, understood them. We took notes, we prepared the notes, and that remained as notes. It never came out for some inexplicable reasons. I do not want to elaborate that. Anyway, Linus Pauling, John Bardeen, Lawrence Schwartz, Rene Thom, Marshall Stone, C.R. Rao, George Andrews, and Paul Erdos. The lectures by the visiting scientists and the members of Math Science have been made as Math Science reports. They are treasures of knowledge. During the annual conferences in the early days of Math Science, distinguished physicists participated. The proceedings were published by Plenum Press as Symposia in Theoretical Physics and Mathematics, edited by Alladi Ramakrishnan, 1967 to 70. And when the institute was created, 1962, there was some difficulty in recognizing the institute to award PhD. That means the students who studied here, they have to enroll themselves in the University of Madras, and there was some difficulty. In due course, this was removed. I think Professor T.S. Santanam was the first student of Math Science to receive his PhD, Alladi encouraged bold and original ideas. That was his hallmark, original ideas. He was enthusiastic to support the novel contribution of Professor Sudarshan of faster than light particles by arranging a symposium. Professor Srinivasa Rao contributed a paper in that symposium. He invited Professor Jayant Vishnu Narlikar to give a talk on his influential work on steady state cosmology in Math Science. When Gell-Mann announced his prediction of omega minus, Alladi termed it as Gell-Mannic impact on high energy physics. In the annual report, he chose the phrase, you can still see, if you happen to go to the library and took out the annual reports of Math Science, you can see this under George Sudarshan's lecture, his picture in the blackboard. Underneath you will see what are elementary particles made of. They are made of fields of Lie algebra. While reporting Sudarshan's lectures on symmetries, this phrase is prophetic, which you know now, it is true. In later years, Alladi became curious in the transition from Pauli to Dirac matrices. I mean, it looks quite trivial, but not so trivial. He gave a prescription called the sigma operation. This was part of his more comprehensive study of omega commutation relations. This came under generalized Clifford algebra, and he gave the name L matrix theory. The omega commutation is Ej, two elements, Ej, Ek is omega times Ek Ej, where omega is nth root of unity. The above was somewhat a precursor to Q-deformed algebra encountered in quantum inverse scattering method on integrable models. Q-deformed version of Bose commutation relations were proposed independently by McFarlane and Bierenhahn in 1989. So a Q-deformed version of fermion anti-commutation relations were proposed by myself and my collaborator K.S. Viswanathan in 1991. An algebra of Q fermion creation annihilation operators proposed by a f of dagger plus square root of q. F dagger is q to the power of minus nf by 2. F squared is not 0. F dagger squared is not 0. Where the number operator nf, which is not f dagger f, satisfies nf with the f dagger is f dagger, nf with the f is minus f. From here we followed the Schwingert's method to develop Q-SU2, deformed SU2. A novel feature of Q fermions is that more than one Q fermion can be found in a given state, in contrast to ordinary fermions. However, when Q goes to 1, we recover ordinary fermions. So we introduced the Q fermionic numbers as square root of q by 1 plus q times q power minus n by 2 plus minus 1 to the power of n q to the power of n by 2 and its associated algebra. When we applied it to Q fermion gas, that is the fermion gas with the interactions included, we found that Cv, the specific heat at a Cv of Feynman, which is the standard fermion value, times 1 over q plus 6 by q pi squared log q whole squared, where Cv Feynman is a specific heat in the usual non-interacting fermion gas. And then Q fermions, as there can be more than one fermion in a given quantum state, allows mild for Q close to unity violation of Pauli's principle. When the limit Q goes to 1, we recover. When Q is 0.98 or 99, you have a mild violation of Pauli's exclusion principle. In atomic physics, one can look for Pauli principle forbidden transitions. For example, by injecting fresh electrons into copper material, a proposal is to look for 2p to 1s transition. In 1s you have 2, you can have more than 1 now, more than 2, with the delta, the energy difference 7.72 keV. We hope such experiments will be taken up in future. Alladi's research interest in omega commutation relations occupied him and his students for a decade. I have observed that he was always enthusiastic about new and original ideas. In 1979, after his US trip, he gave a seminar on tantalizing discovery. How to say that he supported original and novel ideas. The experimental results of parity violation in electron-neutron scattering, confirming neutral weak currents in Weinberg-Salam theory of electroweak unification. And now I come to the kind of a passionate kind of a paragraph. He retired on 9th August 1983. Though he founded IMSc, he was not given an extension. That is something which I don't know. Here's an example here, an evidence. We all assembled in the hall next to director's office, the old. It was about 7:30 p.m. Then the then Education Secretary of Government of Tamil Nadu came from the director's office and then announced that he is the director, I am the director. Alladi by then left the institute in his car with no send-off. Even after his retirement, his intellectual activity continued. He devoted his time to give new interpretation of Lorentz transformation and developed a broad approach to special theory of relativity. He did not come to IMSc since retirement, except on one occasion, I remember, that was in 1986, when the HEP symposium was organized by IMSc and IIT. As secretaries Ramesh Anishetty, H. Sarachandra and myself went to his house to invite him to give an evening talk. He gladly agreed and came first to IMSc, and then he went to the venue at IIT Madras and gave the talk. I will end by stating that in his research in reinterpreting Lorentz transformations, he was studying higher dimensional generalization of Pythagorean equation. You all know what is Pythagorean theorem, Pythagoras theorem. So if you consider a squared equal to b squared plus c squared, all integer values, for instance, 3, 4, 5 for instance, it is called the Pythagorean equation. You bring b squared to the left hand side, you find a squared minus b squared is c squared. You can rewrite a squared minus b squared as a determinant of ABBA. That was his initial idea, and he used that idea to generalize this to 3 and higher dimensions. And he made a conjecture on a determinant of certain circulant matrix. This conjecture was proved by Michael Waldschmidt in 2000. His academic life was completely occupied. He worked on stochastic processes, elementary particles, generalized Clifford algebra, special theory of relativity, and his spirit of research and appreciation of original ideas will surely continue. I want to show 3 slides. This particular slide you see, I suppose you can see that, and I show this for 2 reasons. You can see Balachandran, Chandrasekhar, Alladi, I think that is Professor Devanathan. And Chandrasekhar, people might have noted that he always appeared in full suit, and that too light blue color, always. I think this is the only picture where he appeared in dhoti and shirt. Not only that, he sat on the ground. This is the picture in which in his house they had a lunch in 1961. I don't know, lunch or dinner, I don't know. This is the inauguration of the math science picture, Alladi, Chandrasekhar and C. Subramaniam. That was 3rd January 1962. And this institute where we are sitting here. The last one, he used to write his diary and print it, and he gave me the diary and he wrote to our Parthasarathy, I can't read from here, who has been fortunate to join the first links of the fold, Alladi, 19th June 1981. So I have given you some of the academic work of Alladi, peppered with some social remarks. So thank you for your patience, and I would like the spirit of Alladi in research saying that original ideas should be encouraged. Thank you very much.
Thank you, Professor Parthasarathy, for such a wonderful lecture. Now I would like to call upon the stage Professor G. Annabalan, Professor N. Vasudevan, and our director to felicitate the speaker.
Oh, thank you very much.
So thank you, sir.
Okay, in conclusion, I would like to call Professor Arijit Samal to give vote of thanks.
Good afternoon. Let me start by thanking Professor Parthasarathy, our own professor, for this engaging and enlightening talk. Thank you, sir. It was really important to remember Professor Alladi in this DA Iconic Week. Subsequently, I would like to thank Professor Vasudevan, Professor Anbalagan, and the Academy of Sciences Chennai for this collaboration and envisioning actually that we could hold this talk here in this birth month of Alladi, which is very important. I also take this opportunity to thank a lot of people in IMSc. Usually we have the culture of sending a mail to all, thanking people after organizing an event. But as you know, the Azadi Ka Amrit Mahotsav actually goes from 12th March 2021 to 31st August 2023. So maybe this is the right time, not wait till 31st August 2023 to send a thank you. So there are many people who are involved. And on behalf of myself and my co-organizer Professor Vishwanath, I'd like to express on record the thanks to some people who have been really instrumental in the organization of both ACCM and IMSc 60 and many more. Clearly, you know, things won't be possible without our efficient administration, the director, the registrar, the admin officer, all the junior administration officers, the finance officers. I express my gratitude to them. I should mention that many times, you know, especially in the director's office, we are sending requests for approvals at late in the night, and the PA and all the office, I would like to express my gratitude to them for facilitating it on a timely basis. We have, I think, through this rich program that we have been organizing, creating a rich tradition of archive on the YouTube of various scientific events. And in this process, there have been few people who have been instrumental. Clearly, the IMSc computer and media team deserves a big applause. Who have been in IMSc, they know how many events have been happening in the last 2 months. So they are constantly working. I would like to clearly express my thanks to Ms. Gayatri and Mr. Kiruba for going out of their way on the weekends to do the work. So thank you, ma'am. Without you, it was not possible. Thank you, Mr. Kiruba. They really deserve a, you know, I think they are the unsung stars, I would say here. Apart from that, I think those who are in the auditorium and outside as well, they I think enjoy the rich high tea that we are having, right? I think it takes some effort to have 5 different menus on 5 days on high tea when we are having, you know, 5 days of high tea if you see, or 4 days of high tea. So I think the IMSc catering team, Mr. Krishna Balaji, Mr. Rajkumar and others really deserve a rich round of applause as well. Of course, there is a outreach committee which is now erstwhile. We have now the new events committee, which is a larger committee. I am sort of a convener of that committee, but I would like to also express everybody there, including the outreach associate and outreach assistants, for any help we receive. That's very important as well. Before I thank a couple of people, especially for the DA Iconic Week, I would like to also mention that we have been able to hold these events because we have had generous support from DAE. Recently, we have our DAE Apex project, especially the project on Center for Science Communication and Mathematics Education. Funds from there have been quite useful and really allow us to hold all these events. I would like to express DAE for that project, which allows us to continue to hold so many events and all these high teas and enjoy a lot of scientific activities. Finally, with respect to the DA Iconic Week, it has been a lot of effort actually to do various things. We are doing last moment posters, the web page of our CUM. And in that context, several of the students who have been working with me actually have really helped out, and others as well. I would like to particularly mention Mr. Gokul Balaji, who is actually in the audience. If you see the ACCUM web page, it's really up to date, timely. It gets done actually in the midnight because he is responsive, and all the posters has got a lot of help from Ms. Priyadarshini, because she has been actually instrumental in getting posters up. For example, we actually decided on having an event yesterday in the night before at midnight. So we got the confirmation and the posters were done and put within a few hours in the midnight. It won't be possible without the students who actually work with me and really support at that hour. So with that, I'd like to thank you all.